Bismillah, in this video we will explain a graphic question. Let us start with this one. Firstly, how to complete the table, how to find the missing values of the table. In this one, we need to find the missing values for the y. We need to find the y when the x equal -1, when the x equal -0.5, when the x equal 1. Just substitute the x by -1 to find this value, then by -0.5, then by 1 with your calculator. You get the answer, or you can use this formula from the function itself. You can write yes x over 2 minus 2 over x. Inside this bracket, put a -1 to find the first value, put a -0.5 to find the second one, put a 1 to find the third one. You will find for the first one, you get these values. When x equal -1, y equal 1.5. When x equal -0.5, y equal 3.75. When x equal 1, -0.5. After that, you need to plot this point. Let me plot this point. The first one, -4, -1.5. -4, -1.5. So, plot this point now. This is the first one. The second one, -3, -0.83, or -3, -0.8, approximately -0.8. -3, -0.8. Then -2, 0, -2, 0. Then -1.5, 0.58 or 0.6. -1.5, 0.6. This one. -1, 1.5. -1, 1.5. -0.5, -0.5, and 3.75 or 3.80. This black line means these points join together and those join together. So we have two parts of the graph. Join these points now. Join. By the same way, we can join the second part of points. 0.5, 0.5, -3.75. By plotting all the points, we get this shape, this for a graph. Now we can answer the question for a graph. Let me start. First, use your graph to solve this equation. X over 2 minus 2 over x equal 1. X over 2 minus 2 over x, this is our curve. When our curve equal 1, this means when y equal 1, to solve this equation or any similar to it, draw a horizontal line y equal 1. Draw the horizontal line y equal 1. Draw the line y equal 1 because x over 2 minus 2 over x, this is y. So when y equal 1, so draw horizontal line or draw the line y equal 1. Now we draw the horizontal line y equal 1, and this line intersect the curve at this point and that one. Drop a line from this point to find the x coordinate for the intersection point. For this one, approximately -1.2. For that one, approximately 3.2. So the solution for this equation, -1.2 and 3.2. Number 2. By drawing a tangent, work out the gradient of the graph where x equal 2. A gradient of a graph at x equal 2 equal gradient of a tangent at the same point. So to find the gradient of a graph at any point, just draw a line, draw a tangent at this point, draw a tangent at this point. Let me back to the graph. Now I draw a tangent for our at x equal 2. This is our tangent. Touch the curve at the point 2 and 0. To find the gradient of this tangent, take any 2 points on the tangent. For example, the same point, which is 2, 0, and any other one, like this point, 3 and 1.1. So we have 2 points now. 2, 0, we have 2 points. 2, 0, this is the first point, and 3, 1.1. Now you can find the gradient for the line. y2 minus y1 over x2 minus x1. 1.1 minus 0 equal 1.1. 3 minus 2 equal 1. So the gradient equal 1.1 over 1 equal 1.1. Now the gradient at the point, at this point, the gradient approximately 1.1. Next one, write down the gradient of the graph where x equal 2. Write down the gradient of the graph when x equal negative 2. Let's go back to the graph. If you draw a tangent at x equal negative 2, you will find this line is parallel to the first one. So same gradient. If the two lines are parallel, same gradient. So the same 1.1. And next one, use your graph to solve this equation. X over 2 minus 2 over x equal negative x. How to solve this equation? This is important because it's repeated in all exam. To solve this equation, graphically, you must draw this graph and that one. But this graph is drawn, already drawn, so you must draw this graph. So to solve this equation, you must draw two graphs. The first one, which is x over 2 minus 2 over x, y equal x over 2 minus 2 over x. The second one, y equal negative x. So to solve this equation, you must draw this graph and that one. Now, this graph is drawn for you, so you must draw this graph. Y equal negative x is straight line, and we know that this line, if this x-axis and this y-axis, y equal negative x is line. So you must draw this line and find the intersection between this line and the curve. Then you can find the x-coordinate for this point. So to solve this equation, you must draw this curve and this curve. This curve is already drawn, so you must draw this one, y equal negative x. Then find the intersection with the curve and the line. This is how to solve this equation. So you must draw the line y equal negative x and define the intersection with the curve. Let we do. This is the line y equal negative x. Y equal negative x. Find the intersection with the curve. This is the first point. This is the second one. Now find the intersection, x coordinate for the intersection point. This one approximately 1.15. 1.15. That one approximately negative 1.15. So 1.15 and the negative 1.15, this is the solution for this equation. So find the intersection, the x coordinate for the intersection point of the line and the curve. The last one, write down the equation of the straight line which passes through the origin and it doesn't intersect the graph. Let we back to the graph. Straight line passing through the origin and not intersect the curve at all. So this graph must be parallel to this line and that one. So its gradient approximately 1.1 and passing through the origin. So this is our line here. This is our line. So passing through the origin, this means it's c equals 0. And parallel to this and that, so it's gradient 1.1. So its equation y equal 1.1x. 1.1x. Or approximately y equal x. Y equal 1.1x. The second one, graph is drawn for you. He asks you about the graph. We have two functions. We have a curve, this curve, y equal fx, and we have y equal gx, this line. So we have a line and curve. The curve fx and the line gx. He need what? Let we firstly find the value of f negative 2. You need f negative 2. Means I need the function when the x equal negative 2. y when the x equal 2. But this for function f, for the curve. Where the x equal negative 2? This is x equal negative 2. So I need to find the coordinates of the y coordinates. So this is y coordinates. When the x equal negative 2, this is the value of y. So you can find which one? Approximately negative 10, negative 16. So approximately negative 16. So from negative 2, drop a line till you meet the curve of fx. Then drop a horizontal line where you will find negative 10, negative 11, till negative 16. So the value negative 16. Negative 16. The next one, I need G0. G0. This for a line, because the line Gx. Where is x equals 0? This is x equals 0. Then drop a line for Gx. You will find approximately 10, 11, 12, approximately 18. Yes, approximately 18. When? Because I talk about Gx, this line. So when x equals 0, g of 0 equal what? Approximately 18. This 18. So you can write 18. Next question. Use your graph to solve the equation fx equal 20. To solve this one, fx equal 20, draw a horizontal line, y equal 20, because fx means y. Draw the horizontal line y equal 20 and find the intersection with the curve. Then find the x coordinate for the intersection point. So fx equal 20, draw a horizontal line, intersect the y-axis at 20, then find the intersection with the curve. Now we draw horizontal line y equal 20. Find the intersection with the curve, with the f. This is the first point. This is the second point. First point, about 1.5 or 1.55. We can say that 1.5. The second one, negative 4.3. Negative 4.3. So 1.5 and negative 4.3. Next one, when fx equals gx. fx equals gx when the curve and the line intersect. Then find the x coordinate of the intersection point. Now this is the intersection point, this is the first point, and this is the second point. The fx and the gx, the fx and the gx intersect at this point and that one. Find the x coordinate for the intersection point. For this one, approximately 1.35. For this one, negative 4. Negative 4.6. Negative 4.5. Negative 4.5. And this 1.35. So 1.35, negative 4.5. Next one, solve this inequality. fx less than gx. F, the curve, g, the line. When the curve less than a line. When the values of the curve, values of y of the curve less than y of the line. This means the curve below the line. The curve below the line. When the curve below the line, let me back to the. If you look to the curve, الكيرف below the line from negative 4.5 till 1.35 till they intersect. الإكس coordinate for intersection point between negative 4.5 between negative 4.5 and 1.35 الكيرف below the line. So ال fx less than gx between this point between negative 4.5 and 1.35. if ال x more than negative 4.5 and less than 1.35. The next one, use the points A and B to find the gradient of the line y equal gx as an exact fraction. To find the equation of the line AB, you have 2 points, LA negative 5 and 40, LB 2 and 10, and also you have a y-intercept which is 18, so it's C 18. So now from these 2 points we can find the gradient, and we have a y-intercept C. We know that the equation for the line y equal mx plus c. Now we can find the m, y minus y over x minus x. So 40 minus 10 y minus y, because you know that a equal negative 540, b equal to 10. So 40 minus 10 over negative 5 minus 2. So 30 over negative 7. Now you have a c 18. So the equation for the line y equal, it's better to write a negative in the numerator, negative 30 over 7x plus 18. Next one, on the grid, draw the graph y equal gx minus 10. Gx minus 10 means what? You have gx now. So gx minus 10, this means y equal negative 30 over 7x. 18 minus 10, this 8, so plus 8. This line and that one, they are parallel lines, but the difference in the y-intercept. So I draw a parallel line for the first one, but the y-intercept is 8. Or you can draw by taking 2 points. Now I need to draw line parallel AB, y-intercept 8. Y-intercept 8, so this is the first point. Yes, this. Y-intercept 8. And a distance between the two lines 10. This 18, this 10. So then you can go down 10 for A, this is the second point. Then join this point. So this is our line. This line parallel to AB, but the y-intercept difference, the y-intercept 8. So draw a line parallel AB but different in y-intercept. Next one, draw a tangent to the graph of y equal fx at negative 3 and negative 27. Then write the equation for the tangent. Draw a tangent at this point, then find the equation for this tangent. Let me draw. This is our point. We need to draw a tangent for this point. Let me draw. A tangent will be parallel to x-axis. So its equation y equal constant. In this case, y equal negative 27. So it's the equation for this line y equal negative 27. Y equal negative 27. The last one, a region R contains points whose coordinates satisfy these inequalities. X more than negative 3 and less than negative 2, more than or equal negative 3 and less than or equal negative 2, y less than 40, and y more than gx. On the grid, draw a suitable lines and label this region R. The last one, y less than or equal 40, this line y equal 40. So less than or equal 40 below the line. X between negative 2, negative 3 and negative 2. So draw the line x equal negative 3 and x equal negative 2 and the x in between. So I need less than y equal 40 and between negative 3 and negative 2 and more than gx, this is gx, more than gx. So I need a region that satisfies these three inequalities. Between 2 and 3, less than 40, so below, more than gx, so above. So this is R. So this will be R. This is our region. Firstly, number 8, complete the table. Use your calculator to find the missing value. So the first one, 2 power negative 2, then 2 power 3, then 2 power 4 to find the missing value. So put the value of x, then find the value of y with your calculator. You will get 2 power negative 2 equals 0.25, 2 power 3 equal 8, 2 power 4 equal 16. Let me complete the second table. By the same way you can complete by put x, then find the y. You get negative 1 and negative 5, 2 and 4. Now let we plot the points. For fx, negative 2, 0.25. So negative 2, 0.25, approximately at this point, approximately this point. Next point, negative 1, 0.5, negative 1, 0.5, negative 1, 0.5, this point, 0, 1, 0, 1, then 1, 2, 2, 4, 3, 8, 4, 16, 4, 16. This is fx. Let me join the points. Now for g, the first point, negative 1, negative 5, negative 1, negative 5. So negative 1, negative 5, 0, 0, 1, 3, 1, 3, 2, 4, 3, 3, 4, 0. Let me join the points. Join the points, smooth curve. Now let me answer the question. The first one, solve the fx equal 10. fx, the red curve. So draw a horizontal line. Intersect the y-axis at 10. Then find the intersection with the curve. Then drop a line to find the x-coordinate. This is how to solve this equation. fx equal 10. Draw a horizontal line at 10 when y equal 10. Then find the x-coordinate for this point. Let me do. This is the horizontal line when y equal 10. Then drop a line to find the x-coordinate. You will find the answer approximately 3.3. So the answer 3.3. Next, when fx equal gx, fx equal gx when the two curves intersect two curve intersect at this point and that one. Find the x coordinate for this one. You will find that this one is 2 and this one approximately 0 0.3. 0 0.3. You have a range, so don't worry. So 0 0.3 and 2 intersection point. Next, if negative 1 of x equal 1.7, how to solve this one? It's better to solve by this way. You can write x equal f 1.7. So just will f negative 1 go to the other side and will be f, not f negative 1. So I need f 1.7. How to find f 1.7? So try to find 1.7 on the x-axis, this 1.7, and go up till you reach the fx and go horizontal to find the value. You will find the value approximately 3. Next one, you can complete the table by the calculator, then plot the point. The first point, negative 3, negative 9.7. Let me plot the point. Negative 3, negative 9.7. This is the point. The next point, negative 2, negative 5. Negative 2, negative 5. So negative 2, negative 5 in this. Next, negative 1, negative 3. Negative 1, negative 3. Negative 1, negative 3. Next, negative 0.5, negative 4.3. Negative 0.5, negative 4.25, approximately negative 4.3. Approximately this one. Negative 0.2, negative 10. Negative 0.2, negative 10. This is the point. Now we said that this line means join these points together and those together. So now you can join these points. Join. By the same way, we can plot the points in the other side. Let we do that. After we plot the points, join the point. Now solve fx equal to fx equal to horizontal line at a 2. Find the intersection. Find the x coordinate for intersection as the previous one. So 0 0.7. 0 0.7, approximately 0 0.7. So the fx equal to when x equal 0 0.7. Next one, find a value of k so that fx equal k has three solutions. If fx equal k, this means I need to find horizontal line, draw a horizontal line such that has 3 solutions. This means intersect the curve at 3 points. So I need horizontal line because fx, this means y. fx equal k, this means y equal k. So this horizontal line. So I need horizontal line intersect the curve at 3 points. Find a value for k so that fx equal k has 3 solutions. Let me back to the curve. Horizontal line intersect the curve at 3 points. Any horizontal line in this region intersect the curve on 1 point, 1 point, 1 point, 1 point. Then at this point, out this just 2 points. Below, any horizontal line intersect the curve at 3 points. So you can choose LK equal 4, LK equal 5, LK equal negative 4, equal negative 5, equal negative 6, equal negative 7, negative 8, negative 9. Any value does work, or in between. Yeah. So if you choose LK less than negative 3, does work, because now you have a horizontal line intersect the curve at 3 points. So any value less than negative 3. So negative 3.5, negative 3.6, negative 3. Because if you told you I need an integer, so you can use you take a whole number like negative 4, negative 5, negative 6. So if x equal k has 3 solutions, this means intersect at 3 points. So you must take k in this part, so any value for fx equal k means y equal k. So choose any value for k from this region. Look for this region. Start less than negative 3. So negative 3.1, negative 3.2, any value in this region does work. But you can choose negative 4, because if you draw a line, yes, if you draw a line, this intersect the curve at 3 points, so negative 4 does work. Also negative 5, negative 6, negative 7. Next one, draw a suitable line on the grid and use your graph to solve this equation. How to solve this equation? 2 over x minus x squared, this is your graph, and 5x, this is new for you. So you must draw the line, this line, and this drawn for you. I said before, you must draw the new one, y equal 5x, because this is drawn for you. To solve this equation, you must draw this graph and that one. This is drawn, so you must draw this one. So you must draw the line y equal fx. You must draw the line y equal 5x. And then find the intersection for this line with the curve. Then find the x coordinate for the intersection point. So to solve this equation graphically, you must draw function for this one and that one. This is drawn, so you must draw this one. You must draw that one. Y equal 5x. Draw the line y equal 5x. You can take any 2 points, x, y. If you put x equal 0, 5 times 0 equals 0. So this is the first point. If you put x equal 1, 5 times 1 equals 5. So 0, 0, 1, 5. Then you can draw the line. This is the first point. The second point, 1, 5. Draw the line. This is a line y equal 5x. Y equal 5x. Now find the intersection with the curve. This is the first point. This is the second point. To find the x coordinate for the first point, drop a line from this point. Drop a line to find intersection. This is not accurate, but we can. This is approximately 0.55 or 0.6. Approximately 0.55 or 0.6. The second one, approximately negative 0.75. Negative 0.75 and 0.55. The next one, draw a tangent to the graph of y equal fx at the point when the x equal negative 2, and use it to calculate and estimate the gradient of y equal fx at x equal negative 2. To find the gradient at x equal negative 2, you must draw a tangent at this point, then find the gradient for this tangent will be equal the gradient of the function at this point. Let we draw the tangent. When x equal negative 2, this is our point. This is our point. this when x equal -2, then draw a tangent to this point. This is our tangent. Now, how to find gradient for this tangent? Take 2 points. The first point, this one, which is -2 and -5. So the first point, -2, -5. The second one, we can consider this second point, which is -0.6 and 0, -0.6 and 0. Now we can find the gradient, y2 minus y1 over x2 minus x1. So -5 minus 0 over -2 minus minus, so plus 0.6. So -5 over -1.4. Now you can find the answer, 3.57.